Section A6, Solving Inequalities. Again, if you need help with the interval notation, feel free to look up the Algebra 2 videos that are on the channel. They're labeled interval notation. I've written about them on pages A10 and A21 of the notes that you'll be sent. Solving linear inequalities is just a review of Algebra 1. You should remember to reverse the inequality. Here is when it's written in X notation, and this is interval notation. Your conjunction is a squeeze play. It represents an and. You still need to isolate the x, so I have to subtract 3, not once, not twice, but thrice. I have to divide by 5, not once, not twice, but thrice. And again, I get my x notation answer and my interval notation. A disjunction has your or in it, and it's a left end and a right end. Typically, and I solved it, I have the or. Nothing new here, just a quick review. Now, we want to spend some time on absolute value. When do I have a conjunction and when do I have a disjunction? Some books just want you to memorize what your answer is. They'll give you a theorem. But there's two ways to think of it. One is that this is a less than. Less means and so it's a conjunction. So I would get the squeeze play. The other is that greater than is more, which is or, which is the disjunction. So I get the left end and right end. I prefer overall to think about what's happening in the problem. When I have a less than, note I'm heading less than the given number. But what's the mirror image going to do? The mirror image is going to go on the opposite side and reflect to the other direction. And hence you're seeing here is heading towards the mirror. Here is the mirror image. And that's the idea behind absolute value. You can see no arrows are shaded. So this number is less than your stuff is less than. And so if it's just an X, you see whatever the number is, the opposite, the negative, the positive, and I can come up, the negative, the positive, I come up with my answer, and I'm a squeeze play. On a disjunction, rather than the more and the or, you can just say, oh, here's the particular number, I want to be greater than. And so now where's the mirror image? It's going to head left since this headed right. And so immediately you see that your blah is less than the negative number and blah is greater than the positive number. What's even nicer on a disjunction is that this arrow, blah is less, that's the less than symbol, and that's where the greater than symbol came from. If it's just an X, you can see there's no issue because then this is just less than negative A, greater than A. Now, this is the theorem that the books teach you. Memorize this, memorize this. I like you to think it through. So up here, your teacher thought it through. She showed you all less and conjunction if I want to do it. But what did I really do? I said, oh, I'm going less. The other end's going greater. The arrows are meeting in the middle. So this is a conjunction. And the negative 7's here and the positive 7's there. And now I take my conjunction and I add 1, not once, not twice, but thrice. And I write it in the two forms. What happens when I see absolute value greater than? So the arrow goes to the right. The mirror image is obviously arrow left. And I set up my two inequalities and I solve. And I end up with two separate inequalities joined by or interval notation with the union. Now, quadratic inequalities. We're going to use what I call plus, plus, minus, minus charts. And you can look through the videos and see more about this if you need to. In Algebra 2 videos, if you have questions, just ask. And I can refer you to which video on the channel explains it so you will understand. But basically, here's your number line. You have negative numbers. You've got 0, which is a number all by itself. To 0 and positive, the three types of numbers we have. How do you indicate negative algebraically? You say x is less than 0. How do you indicate 0? X equals 0. How do you indicate positive? X greater than 0. So now, when I come down here and I just say x, what makes it 0 is 0. So, who's playing 0 for x is actually 0. And so what's on the left is negative. What's on the right of 0 is always positive. Please look, negative, positive. I give you x plus 5, and I say what makes it 0? Negative 5. So x plus 5 is 0 at negative 5. So notice this is where it happens. X plus 5 plays 0 here, so x plus 5 plays negative here. X plus 5 plays positive there. Always works that way. Left negative, right positive. X minus 4. Well, what value of x plays 0? Well, I need to be the number negative 4. Positive 4, sorry. So, if I were to plug in 4 here, I get 0. So notice 4 plays 0. So to the left is negatives. So any value that's less than 4 is going to make it negative. Any value that's greater than 4 is going to make it positive. Now, with this in mind, we're going to put it all in one chart. What happens? Here's your x plus 5. Here's your x. Here's your x minus 5. I list the numbers in number line order. I put in the vertical lines to indicate. So we're going to start out. What makes x plus 5 0? Negative 5. So to the left is negative, and all over here is always positive. I only needed to write it once, but we usually write it all the time to keep us sane. What makes this 0 is 0. So to the left, it's played negative, and to the right, it's positive. What makes x minus 4 0 is the value 4. So left of 0 is negative, and right of 0 is positive. Now what happens if I ask you about the product of x plus 5 times x minus 4? Well, the product of negative, negative, negative is positive. Negative. Of positive, negative, negative is positive. Of positive, positive, negative is negative. Of positive, positive, positive is positive. So notice that this product is negative when I'm less than negative 5 or between 0 and 4. It's positive between negative 5 and 0 and when I'm greater than 4. And it's 0 at negative 5, 0, and 4. This is the idea of what we're going to do to determine what would be the solution to this is less than 0, greater than 0, less than or equal to 0, greater than or equal to 0. You don't have to think numbers other than finding the zeros. So what we're going to do is you'll have an inequality that's quadratic degree or higher. You'll determine the zeros and put them on a number line in number line order, please. Then you'll play the game and you'll say what makes one factor 0, and you'll put the 0 on, and whatever's to the left is negative and to the right is positive. You'll do this for each factor. You'll find the product of the signs like I did up here. And then you'll decide from the inequality symbol where to shade. Should you just shade where it's positive, where it's negative, positive and 0, negative and 0, and then you write the simple inequality. Now, folks, in real life, in absolutely real life, if you were to solve this without plus, plus, minus, minus charts, it drives you crazy. Even if you test a number, it drives you crazy. So notice, if stuff's greater than 0, only positive. Greater than or equal to 0, it means positive or 0. Less than 0 means strictly negative. Less than or equal to 0 means negative or 0. So, I give you a simple one because we'll do harder ones of these in a later chapter when I do this again with you. We'll analyze what makes it 0. 0 and negative 4. Notice I put them in number line order. I want the stuff greater than 0. So I don't want negative, I don't want 0, I only want positive. I listed my factors number line order. So x plus 4 is 0 at negative 4, so to the left is negative, the right is positive. X is 0 at 0, so to the left is negative, to the right is positive. And notice, 0 stays 0, 0 stays 0, negative times negative is positive, positive times negative is negative, positive times positive is positive. Now, what did I say I wanted? I said greater than means only positive. So I just shaded where the product is positive. And so there are the two ways of writing your answer. Neither one is more correct. Unless you're specifically told to do it one way or another, no one gives a diddly. Sometimes I believe in your notes I do it this way, and sometimes I do it that way, just to keep you honest. For the next one, what's the analysis? What are the zeros? 3 and negative 6. Notice I put them in number line order. I put in the vertical bars. Stuff less than or equal to 0 means I don't want positive. I put my factors in number line order. X plus 6 at negative 6 is 0. So to the left is negative, to the right is positive. X minus 3 is 0 at 3. So there's the 0. To the left is negative, to the right is positive. The product, if positive, negative, positive. I am looking for negative and 0, so I filled in the zeros and I shaded where it's negative. I don't see any arrows, so it's a conjunction and a squeeze play. And negative 6 is less than or equal to x is less than or equal to 3, or using the square bracket notation for the closed endpoints.